Hello everyone, my name is Al-Zookery. Today I'll be talking about ReadWriteLock. ReadWriteLock pattern our assembly as RWL is a software design pattern that allow concurrent read access to object but required exclusive access for RAID operation. So in this pattern, multiple readers can read the data in pattern but exclusive lock is needed. Will write the data. When writer is writing the data, readers will be blocked until the writer is finished writing. So readers writer problems are example of common computing problems and concurrency. Controls access to shared resources allowing concurrent access to multiple threads for reading but restricting access to single thread for writers or others change to resource. So ReadWriter is an advanced thread lock mechanism. It allows multiple threads to read certain resources, but only one to read it at a time. Just only one at a time. Um, so let's go to the next slide, where for the ReadWriteLock's diagram. Here, the rules by which thread is allowed to lock the read-write lock, either for reading or writing the guarded resources. So let's start with the read lock. For this one, if there is no threads have locked the read-write lock for writing, and no threads have requested a write lock, then multiple threads can lock the lock for reading. The next one is write lock. For this one, if there is no thread are reading or writing, there is only one thread at a time can lock the lock for writing. For this diagram, we have multiple version, exclusive, shared, modified. So let's start talking about the version. For read shared data, it's reported only after it's become shared. They add status to the algorithm when variable is first allocated. It is set to the version status, indicate that the data are new and have not yet been referenced by any thread. Once the data is accessed, it's entered the exclusive status, significant that it has been accessed but only thread only, and the status substance read and write by the same thread to do not change the variable's status and do not update the CV. So this addresses that initialized issue since the first thread can initialize the variable without causing to be refined when and if another thread accesses the variable, then the status change. Read access change the status to shared in the shared status. It's update, but data resources are not reported even if CV become empty. This takes care of the read shared data issue since the multiple threads can read variables without causing race to be reported. Write access from a new thread change the status from exclusive or shared to the shared modified status, in which is updated and resources are reported guests described in the original and some version of the algorithm. So for the reader's writer locking, it's changed the algorithm to reflect lock type. The highlight are the added part that's locked hold purely in the read mode are removed from the candidates set when write occur, such as lock hold by writer do not protect against data race between the writer and some others reader thread. So in this diagram again, the main idea is that multiple threads can read from shared resources without causing a current error. The concurrency error first occur when read and write to share resources occur concurrency, or if multiple writer takes place concurrently. So let's go to the implementation. So in this implementation, so we have binary rewrite used. Um, it's so the program binary to produce a new binary that's functionally identical but include calls to the eraser runtime to implement the lock algorithm. So to initialize the CV for dynamic allocated data, eraser instrument each call to the storage allocator to maintain lock hold for each thread. Eraser instrument each call to occur release lock, as well as the steps that manage the thread initialize and finalize the load represent read storage means rate that for the each load and storage it will update CV. So let's go to the share shadow memory and lock set index. So in this diagram, the shadow memory show how it works basically. So for each variable, like variable ving, it adds and this displacement to its address and then finds the shadow word, namely the index basically. So using this index, in this case, it's 3. To look up like set in this table, and here's how it looks exactly as shown on this diagram. So for the performance, it's actually kind of slowed down by factors of 10 to 30x. So its overhead of making reduces call at every load and stored instructions. Second one, you change the thread order. Third one is affect the behavior of time-sensitive applications. So that's mainly for the performance of the read write lock. So let's go to the common false alarm. So I will start talking about the memory reuse. For the memory reuse, false alarm were reported because memory is reused without resetting the shadow memory. Eraser has no way of knowing that privately recycled pieces of memory is protected by new set of lock, which intersects eraser to reset the shadow memory corresponding to the indicate memory range to the version stats. The second one is the private locks. So for this one, false alarm were reported because lock are taken without communication this information to the eraser at runtime. So we can explicitly pass this information to the eraser. The third one is the binging race. So this one, true data were found that it didn't affect the consistency of the program. Some of these were intentional and other were accidental. They developed a program intention to allow the user of a race to eliminate the false report. So the last one is the races inside the OS. So using interpret system to provide multiple exclusive, this implementicity locks everything affected by interpret level specific. Eraser does not work. So the reason is that OS is quite different from application. Here are the difference. So using interrupt system to provide multiple exclusive, this implicitly lock everything affected by interrupt level specific exclusively associated lock with interrupt level. This blind interrupt is like occurring that lock. The device driver will perform some minimal process and then use V operation to signal thread waiting on um, P operation. For example, to wake up thread waiting for the input, which is IO, and the input and the output of a compilation. So signal and wait kind of synchronize V to signal for B, which way superham and not hold by the thread. So that was basically related to the topic about read write lock. So please, if you have any question or comment, please let me know or let the teacher know about if you have any question. And thank you so much for listening. And have a great day.